This is 3.4. So most of what's in here is going to be review. How do we factor a difference of perfect squares? How does this factor? X minus 7 and x plus 7. Easy enough. Let's make it a little bit harder. How would we factor this? 5 minus 8x and 5 plus 8x. Now, this only occurs, this special type of factoring only occurs when the first term is a perfect square, the second term is a perfect square, and what else do you have to have? It has to be a minus in between. Why would this not work? Right. A negative and a positive would make a negative. Okay. Well, let's turn one of them to a positive. And then you don't get 0 in the middle. Right? When we multiply this out, we get 40 and 40, which do not turn into 0. So these have a special name. Do you remember what they're called? Starts with a C. They are called conjugates. And whenever you multiply conjugates together, so this would be 25 plus 40x minus 40x minus 64x squared. Every single time you multiply conjugates together, you're going to have opposite terms in the middle, and they fight it out and cancel and turn into 0. So every difference of perfect squares will factor into conjugates. Okay. In this one, I need to pull out a 3. Do I need the 3? It depends. If you are trying to figure out where the graph hits the x-axis, then that 3 will not affect your answer. If it's asking you to find the factors, 3 is one of the factors. So in this case, I need the 3. I pull it out, and I get x squared plus 3x minus 30. And that becomes x. Oh, yeah. No 3 there. X minus 5 and x plus 6. So thus far, this is all just review. Okay. Let's not do the grouping one yet. Let's do this one. The factoring rules are the same here, but we have not taught you how to factor if there's a negative in the leading coefficient. So if there is a negative, you need to pull it out. So can I pull out anything other than the negative? No. So I yank a negative out of everything, and I get negative 5u squared plus 8u minus 4. And then I have to factor this one using the box or whatever other method you guys know. 5 times negative 4 would be negative 20. Can we use the factors of negative 20 to create an 8? That would be 10u and negative 2u. Pull out a 5u, and I get u plus 2, and pull out a u. So my factors are u plus 2 and 5u minus 2 with a negative out front. Okay, should all be review. Everybody good so far? Okay. Is this one a difference of perfect squares? No. Is there anything in common between the two terms? A z and a 2. So I can pull out a 2z, and then I'm left with 36 minus 25z squared. And now it is a difference of perfect squares. So 6 minus 5z and 6 plus 5z. Get it? Okay. All right, this one's a little bit strange. Oh, well, that's not what I wanted it to look like, but what can I pull out? A 2u to the third. So 2u to the third, and then I have x to the fourth minus 16. Does that factor again? It actually does. Is this a perfect square? Yes. And we have a subtraction. Is this a perfect square? Yes. Of what? X squared. So this does fit the definition of a difference of perfect squares. It just has a larger exponent than we're used to. So 2u to the third. What would my two factors be of this? And they need to be conjugates. X squared minus 4 and x squared plus 4. Now what? This one factors again. What about this one? No, only the minus. So that one's going to break down into its conjugate pairs. So we get 2u to the third times x minus 2 times x plus 2 times x squared plus 4. That makes sense? You guys good there? All right. Now we're going to do factor by grouping. Okay. Here is a v to the third polynomial. And there are lots of different ways to factor cubic polynomials. And you have to identify which type of cubic it is in order to factor it. And I only know how to factor 2. And I'm only going to teach you how to factor 1. So, excuse me. If you have a cubic polynomial, we are going to try factoring using what we call grouping. Now, most cubic polynomials will not factor this way. Very few of them do. But it's a little trick that will come in handy later. So I'm going to group that together and group that together. What is the greatest common factor of the two terms in the first group? V squared. So I'm going to yank out a v squared. What would be left? 5v plus 6. Okay. Now, this is just a little trick that we've learned that works. So we look at the first two terms, pull out a v squared, and we get 5v plus 6. What is common in the second set? 5. So I'm going to pull out a 5, and when I do that, what's left? 5v plus 6. Now, notice, these are the same. If those are the same, then factor by grouping works. If they're not the same, then it doesn't work. Okay, so now we're going to treat this like a two-term polynomial. Do those two circles have anything in common? They both have a 5v plus 6. So I'm going to yank out the 5v plus 6. So on the outside, I get 5v plus 6 times everything that stayed behind, which would be v squared plus 5. Do any of those break down any further? No. This is not a difference of perfect squares, so it doesn't go any further than that. And that is factor by grouping. Put the first two together, pull out the greatest common factor. Put the last two together, pull out the greatest common factor. If this and this match, then we can pull it out, and that becomes its own factor, and the leftover becomes its own factor. Okay, so let's look at a different type of the same idea. It's a cubic polynomial, so we're going to factor by grouping. I'm going to pull out a u squared from the first set, and I'm left with 4u plus 5. What should I pull out of the second set? Negative 2. So I pull out a negative 2, and I get 4u plus 5. They match. So now I take these out. 4u plus 5 and u squared minus 2. That makes sense? Okay, let me do another one. Okay, let's see if I can do this. Ooh. Oh boy. Well, I want it to end up being a very certain type. All right, what if we had x to the third minus 4x squared minus 9x plus 36? Yeah, that's what I want. Factor by grouping. What do the first two terms share? X squared, and then we get x minus 4. What do the second two share? Oh, something's not right. 9. So it is right. They share a 9. So I pull out a 9, and then I get negative x plus 4. Do my two parentheses match? No. Can I make them match? Yes. What do I need to do? Instead of pulling out 9, let's pull out negative 9, and that would change it to x minus 4. Okay, that might happen to you. So let's yank out the x minus 4, and I'm left with x squared minus 9. Now what? This one is a difference of perfect squares. So we get x minus 4, and then we break the other one down into its conjugates. All right, let me make sure that's everything. Okay. Work on 3.4. Good luck.